All right, welcome back to Math 104. We're going to pick up with where we actually left off, sort of, and that is page 18. We cleared the fractions together, so I want to essentially show you what you should have had you completed the factoring at home. Let's take a look. Let me make sure my video is spotlit. Okay, perfect. Here we have part E. So we started by multiplying by 2 on each individual term, so that way we can clear fractions. We always use this strategy anytime we have fractions in an equation, multiply by the LCD. It's just going to make your life a lot easier. So by multiplying by 2, we're left with x squared plus 16 is equal to 10x. That's where I left you with this problem. Our very first step of solving any equations, any polynomial equations using factoring is that we have to set it equal to 0 first. Notice that I brought over the 10x by subtracting it. And then, of course, my polynomial is always written in descending order. Notice I have x squared minus 10x plus 16 is equal to 0. That's incredibly important. You need to have your polynomial in descending order. Once I see here that I have a trinomial whose leading coefficient is equal to 1, I can say, oh, I have trial and error, or at least I can use trial and error. No one says you can't use AC grouping, but I like trial and error simply because it's a little quicker. So I need to find factors of positive 16 that combine to give me a negative 10. I see that that's definitely negative 2 times negative 8. The beauty of trial and error is I can go right into the actual factored form. So it must become x minus 2 times x minus 8. Whenever I factor, I always do a quick check to make sure I have the line before. So we have x squared minus 8x minus 2x, which gives us negative 10x, and then plus 16. So I'm very confident with that factored form. In order to solve polynomial equations, we then have to set each factor. X minus 2 is your first factor, x minus 8 is your second factor. Yes, princess, no worries. Set each factor containing a variable equal to 0, and we solve. When we do this, we find that x is equal to 2 and x is equal to 8. So we write our solution set in braces, and voila, you're done. Any questions on part E?
Does the order of the numbers matter?
No,
Yeah.
no. You could write 8, 2 if you want. You're essentially just listing the solutions. I will say that in Lumen, sometimes it says what's the smallest or what's the largest. So just be really, really careful with that. But in terms of just listing the solutions, no, that's fine. You can just list them one at a time.
All right.
Excellent. Let's take a look at part F. So for part F, we began by multiplying by 12. That was our LCD. So we were able to cancel fractions. Notice that we were left with 2x squared minus 9x is equal to 18. We discussed yesterday how we were able to simply reduce. Remember, you're dividing out common factors. So we have our polynomial equation equal to 18, which we know is a problem because in order to solve by factoring, it must be equal to 0. We bring over the 18 by using the opposite operation. And then now we have 2x squared minus 9x minus 18 is equal to 0. Right here, this tells me I'm going to use AC grouping. I have a trinomial. My leading coefficient is bigger than 1. So AC grouping it is. So you take 2 times negative 18, which is negative 36. And I need to find factors of negative 36 that combine to give me negative 9. Turns out my two factors are negative 12 and 3. Now that I recognize my two factors, I replace my negative 9x with the two factors so that I now have a 4-term polynomial. Because I have a 4-term polynomial, I can go ahead and group. Factoring by grouping leaves us with x minus 6 times 2x plus 3. We then set each factor containing a variable equal to 0, and we solve. So your solution set contains your two solutions, which are negative 3 over 2 and 6. As a reminder, we know that we are going to have two solutions because of the degree of our polynomial. The degree of our polynomial is 2. Beautiful. Same with part E. Any questions on F?
I'm a little lost when we got to the part where it says 2x and then parentheses x minus 6 right there.
Okay, perfect. So how we derive this is we have to factor by grouping in this step above. So when we factor by grouping, we always look at the first two terms and see, well, what is our GCF? Notice that if you looked at the 2x squared minus 12x, you see that they have a common 2. And
Oh, okay. Yeah.
yeah, it's okay. No, this is good. This is really good. And we have a common x. So I'm going to factor the 2x out, and that's what leaves me with x minus 6. So let's double check. 2x times x is 2x squared. 2x times negative 6 is negative 12x. So that's where that first piece comes from. Oh,
I had forgot that we were going to be doing grouping right there. Yeah, I got confused.
Okay. Think of the instructions being kind of built in the name, right?
Okay.
Because when you do the whole A times C and then you find factors that give you B, that takes care of your AC part. But then after you rewrite it as a 4-term polynomial, now you got to do grouping. So let the name kind of indicate to you what you have to do when, okay?
Okay.
Beautiful. For the second pair, remember our GCF is a positive 3. We bring that out. And notice that when we divide each term by that positive 3, we're left with x minus 6, which is actually really great because then we say, yes, okay, I did this right. I can factor out my x minus 6 and I'm left with the 2x plus 3. And then, of course, you solve. Excellent question. Part G, same idea. We multiplied all terms by the LCD, which in this case was 4. It's okay if it's your only denominator. That still represents your common denominator, right? It's the only one, no big deal. Multiply every term by it. We were left with 4x squared minus 81 equals 0. Luckily, it was already set up the way that we would hope. And then we recognize that this is definitely the difference of 2 perfect squares. So we can go ahead and factor it as 2x plus 9 times 2x minus 9. This one ended up being really, really nice. As long as you remember the formula for factoring the difference of 2 squares. We set each factor containing a variable equal to 0 and we solve. And we find that the solutions are negative 9 over 2 and 9 over 2. Any questions on part G? Badass. All right. Hopefully you were all able to obtain these answers at home. If you didn't have an opportunity to do this at home, you can always recopy down the problems on a separate sheet of paper and then try them fresh without looking at your notes, okay? Maybe give it like a day and then try it out and see how you do. Very cool. We left off on solving for a variable in a formula. And one of the biggest things we had to consider is please, please, please always use the opposite operation to move a term or part of a term to the opposite side of the equation. Then we also learned in part C that, holy crap, we're going to get fancy with it, right? So in Math 104, it goes beyond just, moving terms and being done with it. We had to get a little bit more creative. Recall for part C that we had to get the terms with our variable C together because we saw it in more than one location. We added our C, and then notice we ended up with P is equal to MC plus C. Now, as mathematicians, we were charged with solving for C. But initially that seemed like maybe that's a problem because C appeared in more than one term. Well, remember your factoring abilities. You can simply factor out a GCF. In this case, we factored out the C. When we divided each term by c, we were left with m plus 1, which ended up being really, really cool. Double check, c times m is mc or cm, c times 1 is c. So we know we did this correct. And then all we have to do is isolate c. C is connected to m plus 1 by multiplication. So we say, okay, let's divide. Divide both sides by m plus 1, and you are done. Okay, let's continue this idea and take a look at part D. So I have 1 over a plus 2 over b equals 3 over c. We have a bunch of fractions. What do you think is going to be my very first step? How do you think I would make my life easier? Shout out an idea. Maybe what do you think? Don't be shy either.
Is it by ABC?
Yes, none, welcome. Yes, that's absolutely correct. We are going to multiply by the LCD, which is ABC. Okay, check it out. I'm going to rewrite this because it's a little cramped. So I have 1 over a plus 2 over b is equal to 3 over c. I'm going to write each term in parentheses, 1, 2, 3. And I'm going to multiply every term by my LCD, which happens to be A, B, C. As we move through Math 104, you're going to see that your common denominators can get pretty crazy, especially next unit. You're going to see that it gets kind of a little bit intense, but in a good way. Notice for our first term, when we multiply by ABC, we can actually divide out A. So we're left with BC times 1, which is just BC, plus. For our second term, we're going to divide out B. That leaves us with AC times 2, which is simply 2AC. For our third term, we're going to divide out C. And we're left with 3 times AB, which is simply 3AB. Perfect. Now I want you to consider what it is that we're solving for. We're trying to solve for A. Someone give me my next step. What might I do now, considering I'm trying to solve for A? What might be my next move?
Bring the 3AB over.
We could. Now check this out. If I bring the 3AB over, that's actually good because I'm putting these two together. But what about this dude? Shouldn't that go away? It should, right? Think of it as like you want to solve for A's and you wanted to bring the 3AB over to the 2AC because they're essentially, they both have an A. So they should be on the same side of the equation. But then we would have to say, let's move BC. How about instead, we bring the 2AC over to the 3AB? Only because this one's by itself already. But we can, if you wanted to, you could bring the 3AB over and then the BC to the right. So instead, how about we take a little shortcut, just a tiny one. We're going to bring it over. Notice that our terms are opposite here, 2AC and a negative 2AC. They cancel, leaving you with a 0. 0 plus BC is still simply BC. And then these are not like terms. Please don't combine these. These are not like terms. The A's don't cancel. Nothing happens with these other than we write 3AB minus 2AC. Okay, they're not like terms. We can't actually combine them. All right, someone else. Notice we have an A in each term. What strategy do you think we would use at this point in order to help us isolate A? At this point, what should we do? What's the magic word? We are going to, it starts with an F. We've been doing
Factor.
factor. We're going to factor. What's the first step of factoring? I forgot.
Right. Sorry.
GCF.
Yes, GCF. The first step of factoring, no matter what, is GCF. if you're looking at these two terms, what is your GCF?
A.
Yeah, A. Isn't it the only thing they have in common? Greatest common factor. Look for what they have in common. Don't overthink it. So they both have a common factor of A. If I factor A out, what am I left with?
3b minus 2c.
Perfection. 3b minus 2c. Remember, we're trying to solve for A, so we actually have one tiny step that's left. Who can tell me how I get A completely by itself?
Divide 3b, subtract 2c.
Yes, divide both sides by 3b minus 2c. Perfect. We know that we can divide by 3b minus 2c because of the fact that A is connected to this set of parentheses and everything inside of it by multiplication. So the opposite operation is division. And there you have it. Your final answer is BC over 3b minus 2c is equal to A. What can I help you with? Talk to me. Did that make sense? Can you do that again? Okay, I think some of us are being a little shy. Don't hesitate to ask questions if you're unsure, okay? But again, you'll have the opportunity to practice these kinds of problems in Lumen. So I would urge you to make sure you're practicing these techniques if you ever see them in C&D, and you will see it in the homework assignment. So make sure you're trying those while it's fresh on your mind. Cool. We're now ready to use some geometric formulas. We're not doing a ton with this, so that's why we're already actually almost done with our Unit 1 notes. As a quick recap for your square, all sides are the same. The perimeter for any figure, by the way, is just the sum of the lengths of all the sides, right? We don't have to have a fancy formula for perimeter. Here's our rectangle. We have 2 lengths, 2 widths. Here's our triangle. All sides do not have to be the same. It does not have to be equilateral. We already know that. And then for a circle, we have something called the diameter and the radius. Again, this should all just be review for all of you. The radius is half the diameter, and you need 2 radii to make a diameter, okay? The circumference is found by using these formulas, either pi times diameter or 2 times pi times radius, okay? In an isosceles triangle, 2 sides have the same length. In an equilateral triangle, all 3 sides are the same length. Okay, just something to keep in mind, some terminology that you should have. The perimeter of an equilateral triangle is 48.6 centimeters. Find the length of each side. Now, we know with an equilateral triangle, all of your sides are the same length. So I'm just going to call this, I don't know, E, because I like using different letters. So because it's equilateral, all 3 sides are the exact same length. We know that the perimeter of an equilateral triangle is 48.6. When you hear the word perimeter, I want you to think sum of all sides. So a really basic equation for this particular problem is to simply say E plus E plus E, right? So E plus E plus E is equal to 48.6. A lot of you are probably looking at that and being like, really, why didn't you just write 3E? Well, here it is. And you can start there. I don't want to limit you in any way. So if you saw this and you'd be like, oh yeah, that's just 3E is equal to 48.6, go ahead and do that. We know that in order to solve for E, we're going to divide both sides by 3. And we find that E is equal to 16.2. What are my units in this case? What's the unit of measurement for the side of a triangle?
Centimeters.
Centimeters. Very cool. And we're done. Okay, no big deal. Find the length of each side. They're the same. So bam, is 16.2. I wanted to just kind of rush through that because it's a pretty straightforward one. 21 is an example of what we've seen in 098. Check it out. Hopefully this is not like making you like freak out a little bit. Like, oh my God, word problems again. The length of a rectangular patio is to be 4 feet longer than its width. If the perimeter is to be 112 feet, find the patio's dimensions. Recall from last semester that we always want to start with, first off, if it's a geometric figure, we should draw the figure. So here we have our rectangle. I urge you to draw your figures every single time. It helps to connect the process with the visual. I promise it's really, really helpful. Christina, last semester, when we saw something like this, and I'm going to underline it, we always wrote it as an algebraic expression, right? So for instance, if I write length is equal to, how would you write, Christina, 4 feet longer than the width? Word for word interpretation, how would you break that down? 4 feet longer than the width. Give me the algebraic expression, and you're on mute. There you go.
4x plus w,
You're so close. You don't need the x. You
or
don't need-
4 plus w.
Yes, perfection. I want you to notice that Christina used W for the width. Please do that. Please, please, please do that. It's going to make your life easier if you use the variable associated with the name, okay? So the length is 4 feet longer than is addition, the width. So we use W for the width. Notice here that I'm writing out my relationship. The second thing I do with this information is I actually dress my rectangle. I don't just leave it naked over here, just sitting here naked and afraid. Okay, we're not going to do that. The length of the rectangle is 4 plus W, so we're going to label both sides. The width of the rectangle is simply W, so we label both sides. Now our rectangle is fully dressed. We're told the perimeter is 112 feet. Some of you may write 4 plus W plus 4 plus W is equal to 112. Or some of us may write W, that's 4 W's right here. So 1, 2, 3, 4 W plus, and then we have a 4 here and a 4 here. So if we combine like terms, 4 and 4 make 8. And that's equal to 112 because that is our perimeter. All right, we can simplify as we write our equation if your heart desires that. Okay, don't feel like you have to write it out completely. Let's go ahead and solve by subtracting 8. So we have 112 minus 8. What's that going to give us? You have calculators.
104.
Cool. Divide by 4. What do you get? Who punched it in?
26.
4. 26. Good. Keep in mind that that does not mean that we're done. So Tiana, when you see an answer like this, and we talked about this last semester, when you see an answer like this, what does this tell us? What does this even mean?
You need to plug 26 in for the width. in the
Yes.
equation.
Yeah, and actually you just, I love it. Yes, you're totally right. You said it. Don't we have to plug in the 26 into the width equation? Yes, because this is part of our relationship. So Tiana, what you just told me is that the width is 26. I do like the fact that you commented on plugging back in, because that tells everyone that, okay, if I wanted to find the length, then I need to plug it in here as well, right? So it works to remind us that we need to use a relationship. So I want you to consider here that we know that the length is equal to 4 plus W, and W is 26. So the length is 30. What are my units?
Feet.
Yes, 30 feet. Perfect. And then we see that our width is 26 feet. I want you to really think about that always always, always use your relationship. This is why we write it out in the first place. The relationship is what you want to take your solution and plug back into so that you can actually write out your answers. You don't plug the 26 back into the equation itself, because all that's going to do is it's going to help you check. So you could put 26 here, 4 times 26 plus 8, it gives you 112. Cool, great. But we want the length and the width. So we go back to where we have written down the length and the width relationship. All right, this is going to be really important. Please don't forget this, okay? I'm going to write here that this represents our relationship. Good. And the visual is going to be super helpful. If you have a visual, go ahead and draw it. Turn the page whenever you're ready. Wow, I'm struggling. I am struggling. Cool. Let's get into area. Area is essentially two-dimensional space, right? So for instance, if we were thinking about renovating a room, if we wanted to replace the trim, that would be perimeter. If we wanted to replace the carpeting, that would be area, right? 2 dimensions versus 1 dimension. Its calculation involves multiplying the lengths of 2 perpendicular sides. So in essence, to find the area of a square, you're just going to take this side and multiply it by the other side, right? Vertical, horizontal, and bam, we cover this space here. The area of a rectangle, length times width. Notice that these dimensions are perpendicular, right? They're perpendicular to one another. They form a 90-degree angle. You can see that here and here. For our triangle, if we wanted to find the area, we're going to do half the base times the height. Again, notice the dimensions, your base and your height form a 90-degree angle. So be careful with the height of a triangle. You want to make sure it goes from the base to the vertex. And then the area for a circle is pi r squared. So we have here pi times radius. That's the same as pi r squared. Again, notice here that we have that perpendicularity, right? Radius times radius. Good. Why don't you go ahead and do problem number 22. A triangular sign has an area of 6 feet squared. Find the base if we know that the height is 4 feet. And I'm hoping that you draw this. So I'm only going to give you a minute. You don't need to take too much time. Draw the triangle, label the dimension that you're given, and simply solve for the base. So I'll give you a minute starting now. We're about to get to some really fun stuff. Okay, let's take a look. So here we have our triangle. And we see that the height is 4 feet. So the height of this triangle here is 4 feet. What we don't know is the base, but we do know that the area is 6 feet squared. So we start by noting that the area formula is half the base times the height. The area is 6, so we replace area with 6. We don't know the base, so we'll leave that be, but we do know the height is 4. There's a couple ways to solve this. I'm just going to show you how I would do this. Notice here it says half times the base times 4. I would just multiply half and 4, right? Half of 4 is 2. So we have 6 is equal to 2 times the base, and then simply divide by 2. And we find that 3 is equal to b. Don't forget your units. We find that 3 feet is the base. Okay, good. Let's take a look at 23. Find the amount of fabric in square yards to the nearest tenth. By the way, whenever you see square units, think area. Always, always, always. Square units, area. Even if it's surface area, it's still area. Needed to cover a swimming pool that has a radius of 15 feet. So we're covering the swimming pool. It has a radius of 15 feet. Right away, that tells me circular pool. Oh, that's a terrible drawing. Our radius is 15 feet. And we essentially want to know how much coverage we need. So we're just going to go ahead and use the area formula for a circle, which is pi r squared. While in class, unless otherwise specified, let's use the approximation for pi. Let's use 3.14 while we're in class. I will tell you that Lumen sometimes asks you to use 3.14, and then other times it asks you to use the actual pi key on your calculator. So if you pressed pi and just pressed enter on your calculator, it gives you that many digits of pi. So be careful. Always, always look for the text that tells you what it's looking for specifically. We don't know the area. We know pi is 3.14, and we know the radius is 15. Okay, go ahead and punch this into your calculators carefully. And when you have it, please share the area for the swimming pool cover. Hopefully you all punched this in real quick. Get active with it. Take your calculators out. Try it out. Who's got the area?
$94.2.
I got something a little bigger. Did anyone get something bigger? Oliver, Phil, yes, that is correct. So what is being shared in the chat is 706.5. Notice here that my units are square yards, right? But what we just did here is we calculated the area in feet. So the radius is 15 feet. So the area here represents feet squared. So there's a couple things we could do. We could understand the conversion, which is the relationship between yards and feet. Does anyone know what is the relationship between yards and feet?
3 feet equals 1 yard.
Yes, very, very nice. There are 3 feet in 1 yard. Let me show you a trick. Oh, Dimitri, great question. I just used 3.14 as my approximation instead of the pi key, just so that we can all have the same answer. I wanted to show you a trick with this, because if we want to convert square yards to square feet, I want you to think about the idea of what it means to square a number, right? So if I take 1 yard and I square it, that means I have to take 3 feet and also square it, right? Because what you do to one side, you do to the other. Well, 3 times 3 is 9. And feet times feet is feet squared. And then 1 times 1 is 1, and yard times yard is yard squared. So we just found another conversion. So for every 9 square feet, we have 1 square yard. Well, I have 706.5 square feet. So for every 9 of them, I have a square yard. What we're going to do in this case is we're going to take the 706.5 square feet and we're going to divide by 9. When we take that 706.5 and we divide it by 9, that leaves us with 78.5 square yards. And there is your final answer. So always be super, super careful. Not always are your units going to be exactly identical. So we have to make sure we fix that. If you wanted a quick way from the beginning, you could have just turned this into yards and then done the math. How many yards is 15 feet?
45.
Well,
Wait, no, I did it wrong. I did it the opposite way.
the opposite, yes.
5.
Yes, exactly. If you have 15 feet and every 3 feet is 1 yard, then we see that we have 5 yards here. If you wanted to and convert that, you wanted to convert that first and said, oh no, that's just 5 yards, you would take your pi times your radius, which in this case is 5 squared. There it is. Same answer, 78.5. So either way, I just wanted to show you options that you have for this particular problem, okay? But again, this is not the juicy stuff. We are going to, Dimitri, when you punch this in, did you do 3.14 and then 15 squared? Like,
Oh, no, what I was getting was I used the pi button instead, and I was just asking if there's gonna be any issues using the pi button instead of 3.14 in like in homework or test or anything.
and on homework, yes, be careful, because Lumen will actually ask sometimes for you to use a pi key, and then other times it'll say, no, just use the approximation. So double check, triple check, because yeah, that can make an answer completely wrong if you're not using the correct expression, okay? So just be careful. Okay, very cool. So let's turn the page and get into some good stuff. Applications. Yes, it is time for some word problems. Getting fancy with it. Let's start with our first one, the area problem. A rectangular garden has an area of 180 square feet. I'm going to stop right there. I would like you to draw the figure. Don't label it, just draw the rectangle. Then next to the rectangle, I would like you to write the formula for the area of that rectangle with no values plugged in. Draw the figure, write down the mathematical formula for the area of a rectangle. You should have that your area is equal to length times width. That's where we begin. We are told that the area is 180 square feet. So far, so good. Notice that I'm filling in the blanks. As I progressed through this problem, I drew the figure first. I wrote out the formula pertaining to the rectangle, and then I replaced the area itself with 180. I'm literally just moving left to right. Now it says, find the length and the width. Okay, so find the length and the width if the width is 3 feet less than the length. Who knows how to write that algebraically? 3 feet less than the length.
Would it be L minus 3?
Yes, awesome. L minus 3 is correct. Notice the order, 3 feet less than the length. Because of the word less than, we had to flip the order of the term. So instead of writing 3 minus L, which is a huge problem, we write L minus 3. Also consider, if someone says to you it's 3 feet less than the length, then we know that the length is bigger, right? Because it's 3 feet less than the length. So if we did 3 minus L, we're going to have a negative length, and that's not possible. So the length is simply L. Go ahead and put brackets around this because this represents our relationship. I'm going to write here, relationship. Now let's go back to our equation. We have area is equal to length times width. Well, the length is L, so I'm cool with that. But the width is represented by L minus 3. So we're going to replace W with L minus 3. And here is our equation. I want you to notice that this is the equation we have once we plug in our relationship. It's going to be helpful to notice the figure as well, just to kind of see that visual, that rectangle being completely labeled. This is complete. This is all angles accounted for. Okay. Look at this particular problem. Dimitri, when you see something like this, what is your first gut feeling? What might you do here if you wanted to take a step forward mathematically?
Distribute.
Yes, I love it. So Dimitri says, my gut tells me I've got to distribute. So I get 180 is equal to L times L, which is L squared, L times -3, which is -3L. I love this. Okay, so Summer, when you're looking at this equation here, what is the next thing that you're thinking about doing? What do you think would be your next step?
I was kind of thinking of doing something with the -3L.
Okay. So you were thinking of like maybe trying to like bring that over or something, or what were you thinking?
Yeah, I don't know. I hadn't tried it, but my next guess was probably to add 3L to both sides potentially, and then maybe get rid of the 180.
Oh, interesting. Okay, wait a second. I like what you just said. So do you see how, as Summer and I are conversing, we're kind of spitballing about what could we do, right? So she's thinking about maybe we can mess around with that 3L, bring it over, and then she says, or maybe we can bring over the 180. I love it, because that's exactly what we're going to do. By bringing over the 180, notice these cancel and it leaves you with a 0. Does this look familiar to you all? I hope so. This is your polynomial equation. We learned how to solve polynomial equations by factoring. Shane, which method, which factoring technique would you use in this case?
Trial and error.
Yes, Jose, perfect. We're definitely going to use trial and error. So if we use trial and error, we want to find factors of -180 that combine to give us -3. So we're going to end up kind of playing around and trying to figure out what those factors are. We could list a bunch of them, like 1 times 180. Please don't do that. That's way too small. Same thing with 2 times 90. That's still way too small. Try to think of factors that the factor pairs. What you'll find, did anyone find it yet before I give you the answer? Did you find the factors that give you -3? It's going to be 12 and 15. First off, 12 times 15, that gives us the 180. One of these has to be negative. And we combine these to get a -3. So which one's going to be negative?
15.
Yeah, score. Double check. 12 times -15, -180. 12 minus 15, -3. So those are the two factors. Again, it's okay if you went through each of the factored pairs to check this out. You would just build until you find the correct factored pair. Because we have trial and error, I'm simply going to go ahead and write my factored form. So that is L plus 12 and then L minus 15. And then our last step is to solve. Every factor containing a variable gets set equal to 0. So L plus 12 is equal to 0. and L minus 15 is equal to 0. When we solve this first one, we find that L is equal to negative 12. When we solve the second one, we find that L is equal to 15. This means we have a solution that we are not going to use. The length cannot possibly be negative. I don't know about you, but nobody has ever said to me, hey, I'm going to create a table that's negative 12 inches. What? What does that even look like? That is, somebody's got a problem there. So we're gonna throw away this solution because it's not possible. All we're being asked in this particular problem is to find the length and the width. So Kim, given this piece of information right here, what can you tell me about the length and the width, Kim? What is the length and what's the width?
The length is 15 feet,
Beautiful.
and then the width is 12 feet.
Yes. I want you to notice where Kim got that answer. She knows that the length is 15, so she goes back to the relationship. The width is going to be the length minus 3 units, minus 3 feet. So it's going to be 15 minus 3, which gives us our 12. Beautiful work. This is definitely a little bit more complex than what we saw last semester, but that's the whole point. Hopefully you have a solid foundation where as we moved through the problem word for word, that it actually had a nice flow and made the most sense. Any questions for me on number 24?
This might actually sound like a silly question, but why do I always feel like there can't be, like when we subtracted the 180, I was just kind of guessing. I don't know why in my head, I always feel like there can't be a 0. Like I always feel like they have to be balanced or something has to be on one side. And I'm not
Yes.
sure where I get that.
No, you are correct in thinking that because traditionally that's what you would have to do. Traditionally, you have so much exposure to linear equations. So something like 4x plus 5 is equal to 10, right? Then you'd be like, oh, let's bring over the 5 and divide by 4. Like this is already ingrained in you. These are the kinds of problems you've done 1,000,001 times. But in this particular section of math, the intermediate algebra, what ends up happening is we're starting to look at higher order polynomials. So Summer, the second you have a term that has a degree or power of 2 or more, I want you to start thinking, oh snap, this is totally different. It's not linear anymore. Because it has a higher order, you want to make sure that it's set in standard form. So it opens up a whole slew of new rules. And that is, it's got to be set equal to 0. And then if you want to solve, you have to say to yourselves actually a few things. Can I factor? So if I can, let's do it. If I can't factor, then do I want to use a quadratic formula if it's degree 2, obviously, or do I want to complete the square? And again, that's if it's degree 2. So we're actually going to do all of those things this semester, these 5 weeks. We're going to do them. We're going to learn how to solve using these other techniques. But anytime you see a power of 2 or more, set it equal to 0. Okay. Okay. And actually, unless you see the 0 factor property, but don't worry about that yet. We'll talk about that in a little bit. Don't just.
So the note to put down is if you see a whatever set to 0.
Yes. If you if you see a whatever, set it equal to 0. No, I'm just teasing you. If your power is 2 or more, set it equal to 0. I will tell you that in this class, because we want to learn how to solve quadratics, typically that's going to be your power of 2. Okay, so if you see that degree 2 equation, you see a quadratic equation, set that equal to 0. All right, that specifically addresses what we did last class for solving. Keep that in mind. Excellent questions. All right, take a look at number 25. The product of 2 numbers is 84. What does product mean? Yeah, multiply. So we're multiplying 2 numbers. So then, so we'll pause. We know that we're multiplying two numbers and we know it's equal to 84. So we're going to pause for a moment. It says find the two numbers if one number is two more than twice the other. Okay, so I have my one number and I have my other number. These are my two characters in this word problem. I have one number and I have another number. I'm told that one number is two more than twice the other. How do I write that algebraically? One number is, how do I write that?
Can we get variables first?
You can tell me which one you want.
I guess like A and B.
Yeah, sure. But in which case, having said that, how would you write word for word two more than twice the other?
The number, number one is -2.
Well, you're getting there. So notice it says one number is. What if we just do this word for word? How do you write two more than twice the other?
Oh, you add it. Yeah.
Yes. So we would write two more than plus. How do you write twice the other? And you can use any variable you want.
Maybe like AB, right?
You can just use one letter, not two letters, just one. How would you
Well-
write twice the other?
Would it be 2B?
Perfect. 2b, which means the other number is simply b. What we're doing here in establishing this relationship is we are figuring out how they relate to one another. A strategy that I've liked to use time and time again is by writing the language in the word problem itself. One number is, and then we notice it's two more than twice the other. So we know that we have two characters here, and that's one number and the other number. The other thing I like doing is writing word for word. Don't overthink it. That's the beauty of these. We can write down our algebraic expression word for word. Two more than twice the other. Do you see it here? Two more than twice the other, which means the other is just b. So we have just established the relationship. Now, we are told that our two numbers are one number and other number. And we're also told that the product of both of those is 84. So it would suffice to say that aren't I taking one number and I'm multiplying it by the other number so that I can get 84. Here is my equation written out in words. When we're able to write it out in words, we make that connection mathematically. Now we can substitute in our expressions. One number was called 2 plus 2b. So one number is going to be replaced by 2 plus 2b. The other number was called b, so we're going to replace that. And here is your equation. Oliver, at this point, now that we have this set up, what might be your first step? What's the step mathematically you would take next here? What's that?
I was gonna distribute.
Yes, perfection. You're definitely going to distribute. What Oliver's saying here is that these sets of parentheses need to be dropped. Okay, so we have 2 times b, which is 2b. And we have 2b times b, which is 2b squared. And that's equal to 84. Very nice. Melina, at this point, when you're seeing this particular equation here, what are your thoughts? What might you do next?
Subtract the 84.
Yes. So Melina, in your mind, you're saying, okay, wait a second. I see a power of 2. And this directly reminds me of needing to set it equal to 0 so we can factor. Malina, what would be a good order to write all of these terms? Because this looks like chaos here.
2b squared plus 2b minus 84.
Yes, excellent. Thank you so much. That is perfect. Good. So we're going to go ahead and factor. Didier, what's the first step of factoring no matter what every single time? Oh, you're on mute.
I'm sorry, say that again, please.
Yeah, sure. What is the first step of factoring no matter what? What do we always try to do? The very first thing when we factor.
I'm sorry, I can't remember it.
That's okay. Help them out. That's okay. Help them out. What's the first step of factoring?
GCF.
Yeah.
GCF. GCF. That's your first step. So notice here we have a common factor of 2. So we're going to factor that out. That leaves us with b squared plus b minus 42. We're going to go ahead and cover up the 2. I'm going to move through this a little bit quicker because, again, these are just a recap of factoring techniques. B squared plus b minus 42, that means we're going to use trial and error. Notice we want to find factors of negative 42 that combine to give you a positive 1, that b, that positive 1 there. My factors of negative 42 that combine to give me a 1, that's going to be 6 times 7, right? With our negative being attached to the 6. Negative 6 times 7 is negative 42. Negative 6 plus 7 is a positive 1. I am hopeful that these factoring techniques are becoming second nature to you. They really need to becoming second nature to you. So if you need that practice, make sure you're practicing outside of class. By the end of this week, your factoring should be perfect. And I'm not even exaggerating. By the end of this week, it needs to be on point. So make sure you are mastering that content, okay?
Why does this seem like way too much work when you could just subtract the 2 from the 84 and then go from there?
Well, because notice that it's dealing with the product of the 2 numbers. It'd be different if you were saying like the sum of the 2 numbers, right? If it were the sum, then yeah, just subtract the 2 and then blah, blah, blah. Because of the fact that we're multiplying these 2 quantities, notice that there is no 2 to subtract from the 84. There's a 2b, but even that won't help us because it's not the exact same.
No, I mean taking it a step back behind that even. Like with the 2 plus 2b, right?
Right.
You having that problem, you could just, subtract the 2 from the 84 and then you're left with 2b times b equals 82 and then work from there.
Yeah, and the reason that that's not going to work is because of the fact that it's a product. If it were a sum all day long, think of opposite operations, right? If you had the sum of the 2 numbers and that's equal to 84, then the opposite of sum is subtract, right? You could work backwards that way. But because of the fact that we're actually taking the product of these 2 numbers, it's going to result in different answers. So we have to be careful with how we actually, maneuver through this. That's not to say that you couldn't kind of think about the fact, well, okay, I need 2 numbers. When I multiply them, I get 84. I could look at the products of 84 and then figure out which one has a factor that's 2 more than twice the other. Or you could just go through this. It seems like it's a lot of work, but after you do a couple of these, they're actually going to be really, really fast. And
Oh, I see it now. Because you have to multiply. Not because I'm looking at what I put down and then it adds up to 84, but yeah, it needs to multiply. Yeah.
Exactly. And it's because of that concept. So that's the only reason. But I promise these actually do get a lot easier. This is just the first time you're seeing it. So no big deal. Great question, though, because it's really important to talk about, is that even possible? And especially with this one, because it's a product, not quite. That's okay. Thank you for asking that. So next, we set each factor containing a variable equal to 0. That's going to be this one. We don't set 2 equal to 0 because it doesn't have a factor, right? Excuse me, it doesn't have a variable. So we set b minus 6 equal to 0. We set b plus 7 equal to 0, and then we solve. We find that b is equal to a positive 6, and then we find that b is equal to a negative 7. Now, here's the fun part about all of this. You can actually have 2 sets of solutions, right? So we want to double check this. So if b is equal to 6, if b is the other number, let's write this out. So using b is equal to 6, that means the other number would simply be 6. And that means that one number would be 2 plus 2 times 6. 2 times 6 is 12 plus 2 is 14. So let's double check. 6 times 14, that definitely gives us 84. And we see that one number is definitely 2 more than twice the other. So this one works beautifully. Now, what if we use b as a negative 7? Let's try to write that out and see what we get. So using b as negative 7, we find that the other number is negative 7. And then one number is, we've got 2 plus 2 times negative 7. So if we do 2 plus 2 times negative 7, we have negative 14 plus 2, which is going to give us negative 12. Negative 7 times negative 12 also gives us 84. So you actually have 2 sets of possible solutions. So it could be 6 and 14, or it could be negative 7 and negative 12. In terms of your Lumen homework, it may specify what are the positive solutions, or it may specify what are the negative solutions. So I want you to be careful when you look at this in the Lumen homework, but just keep in mind, it really could be either solution. What other questions do you have on number 25? Good. We're actually just about done. We have 1 page left, excuse me. So let's take a look at this and then we'll take our first break. Number 26. The distance d in feet that an object falls t seconds after it has been released is given by this formula. D is equal to 16t squared. How far will a penny fall in 3 seconds? Do you all agree that how far pertains to distance? And that the 3 seconds here pertains to time? So if you've never seen this before, I don't want you to overthink this. You know that d is equal to 16t squared. Well, it's telling you that t is 3. Let's go ahead and plug 3 in for t. What do you get when you do that math? Jose, what do you get when you punch this into your calculator?
$144.
Awesome. So the distance is going to be 144 feet. So the penny will fall 144 feet in 3 seconds. Perfect. How long? That's time, right? I always like identifying the pieces that we're looking for, the things that we need. So how long will it take a rock that falls from a cliff 400 feet above this C. So we're told the distance to hit this C. Okay, that's interesting. We use the same exact formula. We were given the distance, which is 400. What we don't know is how long it'll take to actually hit this C. Because we have our t squared here, what should my first step be, Phil? What might you do initially here? We have 400 is equal to 16t squared. There's actually a couple things you could do.
Maybe you want to get to 16 by itself.
This,
No.
well, so what do you mean by that? Like, what would you do with this 16? You can help out. Anyone can help. This is a classroom event.
Divided by 16?
We actually can do that. We can do that. Nothing tells us we can't. If we wanted to, we can say, let's divide both sides by 16. There's nothing that tells us we can't do that. There's nothing mathematically that says, sorry, that's wrong. So now we have 25 is equal to t squared. Think back to how you
Square root.
say that again.
Square root.
We could take the square root and use the square root property. You know, it's interesting because in this case, that's going to work beautifully. And I think what we realize here is that you can't have a negative answer, right?
Yeah.
Yeah, because time is positive. So we can use the square root property. We just haven't done it yet. Because I think that you're ready to see a little sneak peek into the future, I am going to take the square root of both sides. Now, the only thing here is that, remember, we are going to have two solutions, right? Because it's t squared. So that means my answer is going to be either a positive or a -5. But you know it can't be negative. Time cannot be negative. This is a little bit of insight into the square root property. That's how you use it. And I'm totally comfortable doing that if you would like to right now. So then what we say is it takes 5 seconds for the object to hit the ground, to hit the C, excuse me. Okay, and we're done. As a little side note, when you had 25 is equal to t squared, you could have subtracted the 25 to set it
Oh,
equal to
yeah.
0. Yeah, but that's okay. The beauty of this is that you can see multiple approaches to the same answer. And the really cool thing is seeing it broken down in factored form, we recognize, oh, that's where those two answers are actually coming from, right? It's this factored process. You know what? I feel like we need to take a break. Do we need a break? Do you guys need one? How are you feeling?
I'm okay right now.
Oh, all right.
I'm alright, but a 10-minute break would be awesome.
Yeah. I mean, how about we take just a few minutes at least? Let's take 5 minutes. Is that okay? Let's just do it. All right,
Yeah,
5 minutes. I'll
thank you.
see you at 10:15. All right, so we are going to finish off by talking about learning about the Pythagorean theorem and using that in application problems. So we have a squared plus b squared is equal to c squared. We've seen these a bunch of times before. As a reminder, the side opposite your 90 degree is always your C, that's your hypotenuse. And then the legs of the triangle are simply A and B. And again, it doesn't matter the order. One could be A, one could be B, it doesn't matter. As long as the side opposite your 90 degree angle, your longest side is your hypotenuse. So we're diving right into something pretty intense. So take a look at 27. It says determine the lengths of all three sides of the triangle. And notice that the lengths of your triangle do not look like anything you've seen before in terms of just your values. not a big deal. We recognize that first off, essentially think of this as like A, your B, and your C. So we can label all three sides of our triangle, but now we're ready to actually write our equation. Being very careful with how we write this in our formula. We know that we're taking A and we're squaring it. X plus 7 should be placed in parentheses so that we could show that we're going to square it. It shouldn't just be x plus 7 squared. It's the entire quantity. We're also going to add b squared, which is x. So that's x squared. And that's going to be equal to our c, our x plus 8 squared. At this point, we recognize that we have squared binomials, so we're going to have to open these up. The only way to do this as a reminder is you would take the x plus 7 squared, you would write it twice, and then you would distribute. So in order to square binomial, you must write it out twice and then simply distribute. So this becomes x squared plus 7x plus 7x, which is plus 14x, plus 49. Bring down the plus x squared, and then we have equals. For the x plus 8 squared, it's the same exact concept. Sometimes it's helpful to actually write out the x plus 8 twice, just so that you can do the math visually, so to speak. X squared. 8x plus 8x is 16x. 8 times 8, 64. Perfect. At this point, I want you to think about what steps you would take naturally next. So, Nung, what might be your next step here? Oh, did I hear a question?
No, I was going to answer.
Oh,
Sorry.
go for it. Do it.
Combine like terms.
Yes, okay. So we have 2x squared plus 14x plus 49. Then we have x squared plus 16x plus 64. What's next? Shout out. What should we do?
Should we make it equal to 0?
Yes, you do. You make it equal to 0. My advice here is you have the larger term, the 2x squared on the left. So let's bring everything over from the right. So we're going to subtract the x squared. We're going to subtract the 16x. We're going to subtract the 64. And there it is, equal to 0. So let's do the math. 2x squared minus x squared is x squared. 14x minus 16x is negative 2x. And then we have 49 minus 64, which gives us negative 15. We have a trinomial, leading coefficient is 1. So we essentially want to find factors of negative 15 that combine to give me negative 2 because we're using trial and error. What are those factors? Shout it out.
5 and 3.
Yeah, 5 and 3. What should your signs be?
Negative 5, positive 3.
Yes. So we have x minus 5 and then x plus 3. When we go ahead and solve these, we find that x is equal to a positive 5 and x is equal to a negative 3. You know that we are going to throw away one of these answers because we're talking about the lengths of the sides of this triangle. So let's throw away x is equal to negative 3. Now, would someone please tell me what are the lengths of all three sides of this triangle?
5,
5,
13,
13.
and then 12.
Perfect. 5, 12, 13. So the lengths are 5, 12, and 13. And that is your solution.
Do we just pick 5 because it's not negative?
That's correct. Yep, you can't have negative length. So there's no way, like for instance, because this one's just X by itself, you can't say that one of the lengths of the triangle is a -3 inches, right? So that's why we say, okay, that's not realistic. We cannot use that extraneous solution.
Yeah, I just had to make sure it wasn't because of some other reason.
Yeah, that's totally cool. Turn the page when you're ready. Last two problems. The length of the computer screen is 1 inch less than twice its width. I'm going to stop right there. I want you to take a second and I want you to write this algebraically right next to this word. So length is, I want you to write down how you would express 1 inch less than twice its width. Just put that right there. I'm going to give you 10 seconds. 1 inch less than twice its width. Okay, type into the chat how you wrote that. Send it to me privately. How did you write 1 inch less than twice the width? I want to see how you're, Phil, awesome. Oliver, beautiful. Nung, perfect. Tiana, beautiful. Kim, excellent. Dimitri, perfect. Oh man, I'm loving it. It's too good, too good. 2W minus 1, which means the width is simply W. We know it's a computer screen. So essentially, we're looking at a rectangle. We're then told the diagonal is 17 inches. Okay. The diagonal is 17 inches. Find the dimensions of the screen. So essentially, we're trying to figure out what is the length and the width of this screen. We called the length 2W minus 1, and we called the width W. What formula am I going to use in this case?
A squared
The
plus
one we've been using.
Yes, Pythagorean theorem, it has to be, right? Also notice we're actually looking specifically at this triangle here. We have our 3 sides. We want to find exactly what those side lengths are. So we're going to use Pythagorean theorem. So let's call A W. So we've got W squared plus B, which is 2W minus 1. I love how matter of fact Dimitri is. I'm into it. And that's equal to C squared. All right, let's do the math. 2W minus 1 squared. We're going to write it out twice. If it helps, write it out on the side just so that you can visualize that distribution. So we have W squared plus 4W squared minus 2W minus another 2W, which is minus 4W plus 1. And that's equal to 17 squared, which is 289. Good. I'm actually going to put you into breakout rooms and have you finish number 26. And then in your groups, go ahead and solve problem number 27. So let's set up these groups. And I'm actually going to make sure that you don't really have a time limit. So as soon as you're done, just come back. Let's see, let's not do a time limit. And perfect. 4 groups of 4, go for it. Okay, so for this particular problem, we're going to go ahead and we are going to subtract the 289 and bring that over. And I'm also going to combine like terms. So let's bring over the 289. And this one's going to end up being particularly tricky. I'll show you some strategies that we can use for something like this. So w squared plus 4w squared is 5w squared. Then we have minus 4w, and then we're left with minus 288, and that's equal to 0. Now for this particular problem, we definitely want to use AC grouping. So I'm just going to write that here, AC grouping. And we want to find factors of, let's do a times c, so 5 times the negative 288, which gives me negative 1440. We want factors of negative 1440 that combine to give me negative 4. So we're actually looking for something that's really, really, really close together. It turns out that those factors are going to be 40 times 36. So 40 times 36 gives us 1440. And we know that the larger factor has to be negative, so that when we combine them, we get a negative 4. I'm now able to rewrite my polynomial. So we have 5w squared minus 40w plus 36w minus 288, and that's equal to 0. Let's go ahead and factor by grouping. So we're going to factor out a 5w from the first two. That leaves us with w minus 8. And then from the second two factors, we actually have a GCF of 36. And again, that leaves us with w minus 8. We have that common factor of w minus 8, so let's bring that out. And we have 5w plus 36. When we go ahead and solve each of these factors, meaning set them equal to 0 and solve, we will find that w is equal to 8, and that here w is equal to negative 36 over 5. We recognize we can't have negative length, so we're going to throw that solution away, and we find that the width is 8 inches, and the length, go back up here, 2 times the width, so 2 times 8 is 16, minus 1 is 15, and there is your width and your length. Perfect. Now for our last problem, we want to determine the area of that entire circle. The issue is we don't know the diameter, right? We don't know the radius. So the first thing we're going to do is we want to figure out the diameter of the circle, which represents the hypotenuse of the actual triangle. So Pythagorean theorem in this case is going to be a heck of a lot nicer. So we have 8 squared plus 15 squared is equal to the diameter squared. So 8 squared is 64. 15 squared is 225. We're going to combine these two terms to get 289. And we recognize that we need to solve for the length of the diameter. And that means that the diameter is going to be a positive or a negative 17. But obviously the negative length is not going to count. So we can write down that the diameter is 17 feet, which means the radius must be half of that. Half of 17 is 8.5 feet. The instructions here were to determine the area. So the formula for the area of a circle is pi r squared. We recognize pi is 3.14. We're going to use the approximation. And we see that the radius again is 8.5. So carefully, when we plug in this computation into our calculator, we'll find that the area is 226.865 square feet. And there is your solution. And that concludes our notes.